All right, so let's say that I have an object and I want to know what its density is. In order to do that, I do need to record the mass. And so I'm going to first off check that this is not magnetic. I'm not going to damage it at all with any water through the way that I'm doing this, okay? But with this object, this non-magnetic object, I'm going to weigh it on the scale very carefully and find that it comes out to be 247.7 grams. So I'll fill out here 247.7, and I'll use my unit, gram. Okay, then I'm going to use the water displacement method. Now, I know I could use math and do the volume of a cylinder equation, but that's not going to be as fun as using a graduated cylinder, which is the process that we're going to do here. Okay, so the first thing is that I'm going to fill my graduated cylinder up with about 50 or 100 milliliters. The object will be covered by the water eventually, so 50 or 100 is usually good for what I go for. Okay, so I'm going to read very carefully what I have. It looks like I have just above 50. Now, first thing, I need to look at my scale. Notice that it's 50 to 100 is here. So that means that this line is 75. So this is 50, 55, 60, 60, 5, 70, 75. Okay, so it looks like I have exactly 50, which is a miracle that I got that, okay? If I got a little bit more, let's just give myself a little bit more for the purpose of demonstration here. Notice how I have above that, okay? What are my sig figs that I'm allowed to have here? Well, I'm allowed to have a digit of estimation, right? I know it's above 50 and I know it's below 55. I can estimate that that is 54 milliliters, okay? And that is what I'm allowed to use for my sig figs. So I'm gonna say that I have 54 milliliters for my volume. All right, so I have the grams of my object and I have the volume of water to begin with. What I'm going to do is I'm going to take my object and I'm going to slide it into this graduated cylinder. Now I have to do this very carefully because if I just drop this in, it's going to splash and all that water is going to splash out. And then I'd have to start the whole thing over again and measure my first measurement. So I'm just going to do this really carefully here and see if I can't slide it in. Slide this in very carefully so it does not splash. All right. Whew. That was close. All right. Almost splashed, but I don't think we lost any water. Okay, now, notice how the water is covering the cylinder. The cylinder is completely submerged. So I can find the volume of this cylinder by taking whatever I have here and subtracting it from my original. Okay, let's look at how much I have here. Okay, it looks like if I know that this is 125 and this is 150, this is right about 140. I'm going to say it's 140 exactly, with that zero being significant because I'm estimating that, okay? So now to find the volume of this object, what I'm going to do is simply take 140 and subtract 54 from that. Now notice how I put a dot here because my tens place is significant because I estimated that and I'm allowed that one digit of estimation. So if I just subtract 54 from 140, I'm going to get 86. And I want to make sure that I have my units here. Am I allowed to do that? Yes, I am. Okay. I can have the tens place there for milliliters. So now to find the density of this object, all I have to do is take 247.7, divide that by 86 milliliters, And I'm going, if I do that on my calculator, I'm going to get a huge long number. Well, I'm only allowed 2 sig figs because I only had 2 sig figs here. And so that number I'm going to round to 2.9 grams per milliliter. Now, not all of these metals match the cubes, but this one is pretty close to aluminum. And honestly, this felt very lightweight. So I'm going to guess that this is an aluminum cylinder here that I have. Not all of these objects that you have in here will be perfect like that, okay? Now, I put aluminum in here. That's fine. For the magnetic metals, which would contain iron, we're not going to use anything that is wet because we don't want it to rust easily. And I've also got things like candle wax here that we're going to measure the displacement of, okay? So you'll notice here, oh, this candle is bigger than this graduated cylinder. So we're going to have to use this graduated cylinder for the candle. Now, the thing with candles is that they are less dense than water. So if I were to use water displacement for my candle, well, the problem is that my candle would actually float, and part of that volume would be above the water, and so I wouldn't be able to actually measure what the volume of the candle is, okay? So that's not going to work. We're not going to use water. So another method that people use to figure out the volume is they use sand displacement. What this involves is, and we want to keep these cords away from the water here, so I'm just going to have a paper towel and make sure there's no water. Okay, what this involves is I've got my nice beaker of sand here, and I've got my graduated cylinder, and it's got its own way of distributing. This is a lot more precise than the other one. And so I'm going to just put in some sand into my graduated cylinder, however much I think I need to surround the candle. Okay, so I'm going to come here and I'm going to kind of tap this out so that the sand becomes as even as I can possibly make it. Okay, so we've got between 70 and 90, which means that this is 80. So it looks like we've got 72, 74, 76, 78, 80. Okay, where does the sand end? 82. Looks like it ends right about 84. Maybe even 83. So I'm going to say 84. If we're honest, I'm kind of mad at VitLab or whoever made this graduated cylinder, because it would have been nice if they had done 81, 82, 83, 84, that kind of thing. But because it's 82, 84, I'm not really sure if it's 83 or if it's 84. And so this is even though this is more precise than this one, it's still not as precise as it could be. So I'm going to be afraid to make a claim that it's like 83.9 or to do too much estimation there. So I'm going to play it safe and just go with the tens place for my measurement. So I'm going to say that my volume of sand before is, sorry, we're going to go for the candle wax down here as an example, is that 84 milliliters of the volume, okay? Now, this is for the example for the candle, okay? You'll be doing things like a rock and a magnetic metal and that kind of thing. But for the candle, that weighs 61.1 grams. So I'll do that here, okay? Every candle is different at every station. So I want to get this candle into the sand just like I had gotten my aluminum cylinder into the water. The problem is if I just dump this in here, it's not going to sink into the sand. So that's why I have my second beaker here. And I'm just going to carefully pour all of my sand into my second beaker without losing any. And then I'm going to put my candle in here. Now, the sand will surround the candle, and then that'll help me figure out the volume of the candle. Wow. Now, isn't that frustrating that it didn't actually cover the candle? So that means I'm going to have to do this over again. Or, because I'm lazy right now, I'm just going to go with the smaller candle instead. Okay, so the smaller candle, I'm going to weigh that one. That is 20.8 grams. So forget this. We're going to write 20.8. Okay, and I'm going to put that one back into my graduated cylinder, and I'm going to cover that one up with sand. Okay, so thankfully we have completely submerged the candle. Okay, now I'm going to look at my graduated cylinder, and I'm going to shake the sand so that it is even. Okay, and looks like I'm at 100, 102, 104, 106, and I'm kind of just above 106, so I'm gonna say about 107 for that one. Okay, try to get down eye level with it if you can. Okay, so the volume of sand after is 107 milliliters. Well, what does that mean? So we've got 107 minus 84, that makes it out to 23. I'm doing a subtraction, so that means I just need to keep the tens place, and that's what I did. So if this were to come out to anything else, then like if somehow I were to get like 23.2, it'd have to be 23, which there's no way that I would get that. All right, so now to find the density of the candle wax, I just need to take the mass in grams and divide it by the 23 milliliters, and that's going to give me the density. Okay, well, that's nice. Okay, so this can be used also for certain wood blocks when you get down to this section.